I wanted to stop snowing.
Okay, well then maybe they should put spring break closer to springtime.
Spring officially starts on March 21st.
Yeah, I know, but that's not when our spring break started, did it?
What? No, but our spring break ended about the same time that.
This is Chicago, not Missouri.
Yeah, whatever.
Our spring does not come as soon as, St. Louis's does.
But officially starts at the same time.
I'm sorry, I know that
Just saying.
marketers and packagers and trains, I don't know if you knew this, but there was a long time ago.
No,
We can talk about that another day.
we can talk about it later, exactly.
Well, we're talking about train systems and time, and remind me to tell you about train systems.
Sure. Okay.
Okay, so today's topic is about test review.
Yes, it is.
Where did I have that? Look in a special pocket.
Ah, nice. Perfect.
Look at all the beautiful red.
Okay.
Enough.
You want to just go through the whole thing? Or
Yes.
are there specific? Okay.
Oh, let me see really quick here. Oh, jeez. I was really nervous during this test, I studied for it, and then all of a sudden, you get to the test and you start blanking out. And I'm writing formulas on my test chair, trying to remember things.
Yeah. You get to the test and you forget one thing. And you go, oh no!
Well, and then it screws everything else up. You keep doing this wrong. Oh shoot! You keep doing this, he says to me.
Okay. Well.
Okay, so I guess we'll start from the top.
What do you keep
Oh,
doing?
that was the last one. That's the last one. So, I'm sorry. That is problem one. That is a part of problem one. I just added additional notes because I didn't have enough space.
Okay.
I added another thing. There wasn't enough paper for this test, so I added more.
Quadratic.
Do you see how there was literally no space for this problem? I write super small. Anyhow, problem solved easily by additional sheets of paper.
Yep.
So I did this, and then these are my additional informational notes. I tried.
Sure. Let's start at the beginning.
Okay.
Give me the quadratic. Y equals -2 per n.
2 parentheses x plus 2 squared, close parentheses squared, plus 6.
Okay. So this is convenient because this is in a times x minus h squared plus
K.
form. Okay.
That's the vertex formula. Yeah, I remember that.
So then.
And then I immediately started thinking, oh, cool. So let's start plugging in some information that my givens, if you will.
Yeah.
So I did y equals -2, and then the x, but it's because it's -2, it's minus 2, which is I close parentheses that.
Yes. So you changed the +2 to a -2. So that means what's h?
And then h,
Based on that.
h is -2.
Okay. H is -2. Good. So what's that? That's the x coordinate of the vertex. Okay. What's k?
The x coordinate of the vertex.
Yes.
Oh, I must have screwed up on the graph then.
You got the x coordinate.
Of the vortex is 2. I put a solid 2 though. Yeah, I put a whole 2 for the vertex.
Okay. So 2 is it's the correct x value for the vertex.
Right, because it's negative and the negative makes it a positive 2.
Oh no! Haha, you're right. Oops, I stopped paying attention. Right.
You were testing me.
Yeah, I was testing you exactly. So yeah, that's the vertex. That negative 2 is the x coordinate of the vertex.
Yeah.
What's k?
K is 6.
Okay, k is 6.
Yeah.
What are the coordinates of the vertex?
Apparently it's 2, comma, K, which is 6.
Okay, so yeah, it's h comma k.
Negative 2, 6. And I somehow got 2, 0. Because I was thinking that the 2 negatives make it a positive 2. Maybe, I don't know what I was doing.
What you did here?
Yeah, right here.
What you did here is you made the mistake of setting, you said y equals 0. And then you solved for y, but you had already decided that y was 0.
Mm-hmm.
You were to 0 here.
Yeah.
So once you do that,
Well, because I was trying to find out.
and then you get x equals 2. So what happened when you did that, is you
Well,
solved,
x equals 2 and I put y equals 0. I mixed up on the
you started solving for the x-intercept.
x-intercept, so the vertex. I could have just figured out the vertex from the problem itself. Which in this case, it looks like it's a whole 2 and a whole 6. No negatives.
Yep, negative 2. Negative 2. X minus
It's
2.
negative 2. Okay, a whole 2.
Minus
Right.
2.
Minus a whole 2 is a negative 2. Yeah.
What do you mean by a whole 2?
As in it's positive. See what it says?
Positive 2.
Okay, positive 2. X minus h. Like say for example, it was x minus 2 in here. Then it would be x minus 2?
Yes.
Okay.
Specify the vertex, axis of symmetry, and x and y intercepts. Okay, so here's the vertex. We know what you did wrong on the vertex part. What's the
Yeah.
axis of symmetry?
That's when I find the dotted line for what x is supposed to be.
Yeah.
And to do that, what did I do? I set y to 0, I think. Yeah. That's what I did.
It's not what you should do though.
What did I do?
So let's draw a random parabola.
Yeah, I just said, well, what is the vertex x coordinate?
Yeah. Yeah.
What did I do? I set y to 0, x intercept, y equal.
So you just, what was that about the x coordinate of the vertex?
I said, well, the vertex x coordinate is 2.
Then you're done.
And I said the axis of symmetry is on x, which is 2.
Not rigorous mathematical language, but the right idea. The x coordinate here is 2. It's pretty clear that the axis of symmetry goes down the middle of the parabola, right? So it goes through the vertex.
Yeah, through the vertex.
So
Vertically through the vertex, that's important to clarify that.
Right.
Which is the same thing as saying it goes down, or vertically through the x value.
yes.
which is in this case is 2.
Mhm.
Oh. I was on the wrong side. I was a negative sign off.
That's fine.
Consistent.
So, assuming that, so you solve for the vertex, and let's say that the vertex was 2, 0.
Mm-hmm.
So, this was the actual vertex, but let's assume that you did the first part right.
Okay.
And you got 2, 0.
Mm-hmm. Okay.
So then, solve, so then
Now we have to find the x and the y. That's easy.
Then the axis of symmetry would be what? Tell me again. Don't give me the process, just tell me what it is.
It is the vertical line running through the x value.
So how do we write that?
When x is
Okay, hang on. Listen to yourself. You're saying x is what?
2.
This is the equation of the line that is the axis of symmetry. You're having trouble going from here to math.
Yeah, I'm just trying to figure out how I can put the English sentence into a math sentence.
All right.
I'm just saying that the axis of symmetry is when x equals 2. Vertically.
is.
Well, you don't even need to say vertically.
I don't. Is it
So-
understood?
First,
Like,
you
how
said-
would somebody know that to do a dotted line up and down?
First, you said the word is, so you don't have to say equals. That's the first thing. Is and equals are the same. The other thing is, if you say that x equals 2, okay, let's find the point where x equals 2. There's one. There's one. There's one. There's one. There's a whole bunch. This is the line x equals 2. If you write this, you don't need to say it's vertical, because you can't do it horizontally.
For someone who doesn't know math, they would have to know that it's vertical. Because they wouldn't realize you do x equals 2 each time.
Well, okay, well, theoretically,
You know what I'm
if you
saying?
got a parabola going this way,
Mm-hmm.
then your axis of symmetry would be this way. And then you wouldn't have to specify. You'd get something different. It would look different.
Mm-hmm.
You don't have to say that it goes vertically. Okay, so this would be the axis of symmetry. You got that, right? Assuming that this is the correct vertex.
I did.
Okay.
And then the x-intercept and y-intercept for this one.
Okay, well, the x and the y-intercept, we kind of have to go back to the original problem. I don't,
So that's y equals -2. I'm basically setting x to 0 to find the y-intercept.
yes.
Y equals -2, parentheses, 0 plus 2, close parentheses, squared, plus 6.
Oh, okay, I see what you mean. So, solve for y-intercept. Was it -2 times what?
0 plus 2,
0 plus 2
squared, plus 6.
equals what?
So that's the 0 just doesn't do anything. It's just a 2 on the inside, and that becomes a 4. So it's -2 times 4 plus 6, which is -8 plus 6, which turns into y-intercept equals -2. Y-intercept equals -2.
Yeah, yes, that's where, okay, so,
How,
So if -1, -2, the y-intercept is here.
Mhm.
Which makes sense, because if you're here, I guess.
But something's gonna tell me, I have a feeling that since the axis of symmetry is -2, the correct one, that the other coordinate is gonna actually be, it's gonna be like, it's gonna be -4, -2. I think that's gonna be the other, I have a feeling. So like, for example,
Here's the thing.
if I would put in
Every-
-4 instead of 0, we would still get -2 as an x.
Yes. Here's the thing. You say, something tells me every time you do that. And every time I do that, every time you do that, I say, yes, that's right, do that. And it seems like you forget that that is the correct way to do it sometimes. It's a perfectly valid way to do it.
Yeah, well, that's how I got this one though.
Yeah.
You know what I'm saying?
But that's,
It's because of something
you
told me
did that
something.
part correctly.
Yeah.
The work leading up to it might have been wrong, and
Right.
that's why your answer is wrong, but that intuition is correct.
That's how we got this 2. Or I was able to graph it. Okay, so and then now we have to do the reverse, or not the reverse, but we have to then now find the x-intercept by setting y to 0. I'll give you the formula again. It's 0 equals -2 x minus 2. Wait, is it? Oh, x plus 2, close parentheses, squared, plus 6.
Yes.
And, okay, in this particular case, let's see if I can do this on the back side. Set y to 0. Okay, so here I got 0 equals -2x squared minus 8x minus 2. What is it?
Sure, let's go with that. So -2 times, what is x plus 2 squared?
That's 2x. Let's see, I factored that out. I basically,
already factored. You can't factor
yeah,
that.
this is what I did. It's minus 2x squared minus 4x minus 4.
Okay, so I wanted this step here, where you say -2 times this.
Yeah, right here, this one right here. X
Okay.
squared,
Yes.
Yeah. this.
Yes.
Wait, and then I took this -2 times all of this.
Yeah.
Are you able to see this?
This is all correct, yeah.
And that's where I got this. So that's why when I just gave you this, this is the work for it.
What's the -2? Oh, you didn't, yeah, okay, then you add the 6. All right, sure.
And then I added the 6.
Okay, so what you did is you turned it into 0 equals -2x
squared minus 8x minus 2.
Then what did you try to do from here?
Here, I want to see something here for a second. And then I added 6, right, to make that a -2. Okay. And then I'm like,
Okay.
and this is where I kind of got stuck apparently. Let's see, what did I do on the front page? I came up. Huh.
I know why you have trouble with this.
So I tried to use the quadratic formula.
First you did this, right?
And I did this.
And what are you trying to do here?
This was just I was trying to go reverse. I was
So you keep doing
I
this.
was I don't know.
So,
I was trying to reverse this out to see if I could, like, for example, what I was doing is, like, let me see what would happen if I just added 6 to both sides back again. And I did that because I was trying to isolate x. My goal was to isolate x and find out
why
what
did you
x
change
was.
this? X is isolated here. Why you unisolated x by doing this whole
By
factor.
foiling it out.
You could have just done this. You have this, you can just you subtract 6 from both sides.
Okay, and then
Divide by -2.
divide by -2.
Take the square root.
Oh shit.
Plus or minus square root of 3.
That could have saved me a whole bunch of time. That could have saved me a whole bunch of time. Square root of this is that. Square root of this is 3. Square root of 3. Now, because we don't know what x is, that square root of 3 could be plus or minus. And then
No.
we just subtract.
No, don't say it that way.
That's what I don't know. Why
When we take the square root, we always say plus or minus. It doesn't matter whether we know what x is or not. If we take the square root, we always have to say plus or minus.
What if it's 3 equals 6 plus 2 parentheses squared?
This is a false statement. So what you really want, what you're trying,
I'm just saying, like,
if
we
there's
don't
an
know.
equal sign, if you have 3 squared equals 9, you would never take the square root of 3 squared equals square root of 9, and then say that 3 equals plus or minus 3. Technically, this is true. One of these is true, one of them is not. We always have to consider both situations. We never know for sure. And when we're dealing with an x that we don't know, it's always both.
Okay. Okay, so, well, that's what I'm going back to, is that when there's an x involved in square roots, you have to do the plus and the minus.
You should always do the plus or minus. If you ever find yourself taking the square root of something,
Even if
do
it's
plus or minus.
even if it's this whole thing with the
Because really,
3 squared equals
really it's
9.
this.
There
Really,
you
it's
go.
plus or minus 3 is plus or minus 3.
Right.
You
on both
never
sides.
change anything if you have all numbers.
Okay, so now that makes more sense than what we did up there then. Plus or minus 3 equals plus or minus 3.
Right. Sure. Yes. But, yes. Yes.
Why not, right?
And then doing that doesn't change anything. So we might as well have written this.
And
It's all the
same
same.
thing for the 9 on that side.
No. Can't do that with the 9, because then you're saying that something squared is a negative number.
Oh, that's right. Okay.
So when you have all numbers, you never really take the square root. It never comes up. And if it does, you can cancel the negative signs.
Okay.
But when we're doing this, you always have to take plus or minus.
Jeez, I cannot believe how I just went through all this quadratic formula,
Well, let's look at the
breaking this
formula.
down, and I just really love making it complicated here.
Well, here's the thing. The quadratic formula should have worked. This is
Okay, let's see if it did. Almost did for me.
Let's write this down again. 0, I'm going to change colors. Because border is black. So we have 0 equals what? Negative 2x squared minus 8x minus 2.
Yeah. Okay, so A equals -2, right? B equals -8. C equals -2. That should have been a warning to me right there. Stop. You're dealing with all negatives. So then it's x equals negative b, or simply, we don't have to write out the formula, right? I'm just going to give it
Yeah, sure.
Okay. X equals negative, parentheses, negative 8, close parentheses, plus or minus. Square root over negative 8 squared. That's negative 8.
Does it matter?
For purposes of documentation,
Okay.
yes.
All right.
Sorry about that.
Okay, fine.
Minus 4 times negative 2 times negative 2. All over 2 times negative 2. Yeah. X equals, so then that came up to x equals 8 plus or minus. Now 2 times, I'm just going to work, 8 times 8 is 64. Minus 2 times 2 is 4, which is, becomes positive. And then positive 4 times 4 is 16. So it becomes 64 minus 16 under the square root, all divided by negative 4. And something went wrong over here. X equals, this is where I get in trouble.
Okay.
Okay, so I made this 48 over 4. And then something went wrong here. I recognized that I could break 48. And I was having a little trouble trying to figure out how to do that.
Well,
like I knew that 48.
so here's the thing. What you ended up doing is you're like, I know I can do something with that.
Mm-hmm.
But then you didn't do anything with it and you canceled anyway. You can't. You can only cancel if you figure out what to do with square root of 48. It would have been better to just stop here.
Yeah.
Well, let's look at what you can do with 48. Give me a perfect square.
Well, 7 times 7 is 49, so
Oh,
that's not a problem. 6 times 6 is 36.
Try to start with small ones. It's easier to figure out whether small ones go in.
Okay. 2 times 2
We
is
know
4.
that this is not. Okay, 4. What is 48? I guess square root of 48 is the same as square root of 4 times what? Square root of...
Square root of 4 is 2.
4 times what is 48? I'm factoring.
4 times what? 4 times what?
48 divided by 4.
I think it's like 12.
It's 12. Yes.
Isn't it?
Yeah.
Yeah.
So then you can pull out another 4 from there. So you negative 4
And there's like,
times
isn't
negative
it
4.
like, yeah.
Or, whoops. I mean, I guess it doesn't really matter, but negative 4 square root of 4 squared times the square root of 3.
3. That's really 4 and 3. Yeah.
And then,
Okay, that's what that
well,
means.
here you end up with 8.
So it's 8 plus or minus 4 square root of 3 all over negative 4.
Now you can simplify. Only now. You have to divide both of these things by negative 4. So what you did wrong is, what you did wrong is you didn't factor this out for dividing by negative 4. You tried to divide by negative 4. Just here. You have to divide by that in both places.
Both on both sides of this plus or minus? Is that what that's about?
You just have to do it to everything.
Oh, so not just half of
So
yeah.
really-
If I'm dividing by negative 4, it has to be everything on the top of the bar.
Yes. Really what you're doing is you're saying negative 4 times negative 2 plus or minus
Yeah,
4.
I'm not making a complete division.
That's
what's going on there.
Right.
So in this particular case, why is it because 4, it's really saying 4 times the square root of 3? That's why I can divide
Yeah.
-4?
Yeah, of course.
Okay.
This is defined to be 4 times the square root.
All right.
That's the definition.
Okay, wow, I can't believe that was just the first problem. Isn't it amazing how? I want to do like a logarithm problem, but maybe we should just stick with this subject for right now. Let's just stick with this subject because everything else is logarithms. We'll do that another day. I'd rather just, I would rather just hammer this.
Okay.
Maybe we'll just touch on number 2 slightly. This is considered the following rational function: y equals x squared plus 18x plus 2 divided by x squared minus 9. Find the vertical asymptote and horizontal asymptote for the rational function.
Find the vertical asymptotes first.
Okay. Find the vertical asymptote. That's when we make the denominator 0.
Yes.
How do we make the, in other words, how do we make the denominator 0?
Right.
So we take the value on the bottom and set it to 0.
Right? Does that make
I
sense?
did it. I think I got that correct. Okay. So I got plus or minus 3. And then,
Cool. So we have the vertical asymptote. Let's
okay,
do
so
the
here's the horizontal asymptote was not as easy. The way we get the horizontal asymptote is,
What's the key word? What's the most important word for horizontal asymptotes?
limits.
Yes. Limit. Now what limit is it?
Well, we want
The limit as you go where?
to limit it. We want to go to infinity.
All right. The limit as you go to infinity.
The limit as we want to go to infinity. So horizontal asymptote.
So limit
It's
is
getting close to but never touches. And
as you go to infinity.
as we go to infinity,
We're taking the limit as you go to infinity of what? Don't try to do this in your head. Try to do this.
I know I'm not. I have to do it somewhere. As x goes to infinity
Of what? What are we looking at? Limit as x goes to infinity
of the y,
of
of the y value, or value of y. Yeah.
Okay.
So in this particular case, what I did is I broke up my, excuse me, I broke it up into 3 parts. And I was trying to figure out,
Okay, well that's a reasonable way to do it if you do it right. Although technically you don't know that works. I know that works. Here, let's.
I was trying to simplify it. I think you taught me that last time or something, and that's why I kind of did that.
So x squared over x squared minus 9 plus 18x over x squared minus 9 plus 2
Oh, I know what I
x squared
did.
minus 9. No, this is good. So far this is good.
Wait,
Do you think you screwed up here or later?
no, I think. What do we do here? Wait, this is a 20. Okay,
I know what you did. I can see what you did right now.
Okay, this is a 0, 0. How did I get this one?
What do you think it should be?
Oh, I know that these two canceled. That's why I got a 190 on the top.
They don't. They don't. If you have x over x plus y, that is not the same as 1 over y. You can't cancel this. The same way that maybe we want to.
I better get going because that professor's a crazy person. I'm so sorry. I have a class at 1:50.
Just watch for a moment.
Okay, I am.
Infinity over infinity. These are the same kind of infinity. They're the same size. Really what happens here is the negative 9 doesn't matter. This goes to 1.
Okay, so
That
they don't
goes to
cancel.
zero.
I thought that they just canceled each other. I got those on the right.
You got those two right. Yeah.
Okay.
The things where you get infinity over infinity are more tricky. But you have to recognize that you got infinity over infinity and then mess with it so it actually
1, 2, 3, 4, 5. Yeah, wow, I'm trying to figure out if I had a little bit more time, so if I had a little bit more time, what's the problem? There's
you're
not enough.
under a little bit less pressure.
Well,
You're under a whole lot of pressure.
yeah, well, that's all right. I'm gonna keep studying. I gotta figure out.
Did you take
time.
activity 2 with you?
Did I? I probably did.
Good.
Okay.
Take it with you.
Okay.
And if you're going over your exam and you see a quadratic anywhere and you think, I don't understand why I got that wrong, do activity 2. Because activity 2 is all about quadratics.
Okay, that's good to know. I will keep that in mind. 1, 2, 3, 4. I have to count my zippers to make sure the zippers are. I know they're 5. I was, There had been a time where I was walking down the street. I can't remember recently because that's been so many years.
Dropping stuff.
Yeah, just dropping stuff. All right, thanks, Morgan.
All right, no problem. You too.
Goodbye, everyone online. Ta-da.